Hey, this is Vicki Gaines. We're doing transformations using matrices. We're working on translations and dilations. Hope you learned something new. Modeling motion with matrices. You can transform shapes by moving them, flipping them, turning them, enlarging them, as well as shrinking them. If your shapes are graphed on the coordinate plane, you can use matrices to find the coordinates of the new image of your shape. Transformations that you can complete with matrices include translations, which we're doing in this video, reflections, which we will be doing in a different video, along with rotations, which is another video, and dilations, which is in this one. Transformations. Draw a line from the term to the correct definitions. I did arrows. So translation is sliding a shape. So those are going to match up. A reflection is where you're flipping the shape. Those match up. Rotation is turning a shape. And a dilation, you're either enlarging or shrinking the shape. All right. What is a vertex matrix? A vertex matrix is a matrix that is created from the coordinates of the vertices of a shape. Here's our example. We have quadrilateral ABCD, and it is the following vertices. A's at the point -1, 5, B's at the point 3, 4, C's at the point 4, 0, and D's at the point -2, 1. This is how it is graphed. Vertex matrix, what's it going to look like? The x values are going to go on top for each of the points, and the y values go in row 2. So x values are in row 1, y values are in row 2, and we have 4 points, so we're going to have 4 columns. Here's a format. So A, the x value is -1, the y value is 5. B, x value is 3, y value is 4. Point C, x value is 4, y value is 0. And point D, x value is -2, y value is 1. So there's our vertex matrix, and we're going to be using it in the example coming up. First, in order to do our translation using a matrix, we need to do a translation matrix. So what is it? A translation matrix is a matrix that's created to show the movement in the x and y values when the shape is sliding to a different location in the coordinate plane. Example, if you want to move quadrilateral ABCD, the one we just did in the example, 2 units to the right and 4 units down, we're going to need to slide the x value in the +2 direction and the y values -4. So translation matrix is going to be a 2 by 3, 2 rows, 3 columns, just like our vertices. This is the movement of the x's, and we're going 2 to the right. This is the movement for the y values, and we're going down 4. So 2 to the right is +2. 4 down is -4. There is our translation matrix. So how do you translate a shape using matrices? So here is step 1, graph the preimage. We already have that. Create the vertex matrix, which we already did as well, and the translation matrix, which we did on the last slide. We're going to add in step 3, add your vertex matrix and translation matrix. The sum of the vertex matrix for your translated image, so that is where we're going to end up. So here is the vertex matrix. We are adding the translation matrix. Here's our format, 2 by 3. So we're going to take element 1, 1, and we're going to add -1 and 2 to get A prime. The x value is going to be 1. We're going to add the 5 and the -4 to get 1 for B prime. We're going to add 3 and 2 to get 5. We're going to add 4 and -4 to get 0. C prime. We're going to add 4 and 2 to get 6, and 0 and -4 to get -4. Last point, D prime is going to be -2 plus 2, which gives us 0, and 1 plus -4, which gives us -3. So there are the points that we would need to graph, and there is the graph after the translation of moving 2 to the right and 4 down using matrix. Quick check. Translate a matrix. So we need to graph the pre-image and the translation. So the image afterwards. We have quadrilateral ABCD. It has the following vertices. So different than the one we just did. So A is at the point 2, 3. We can graph that. B is at the point -1, 4. I'm creating my vertex matrix as I'm reading the problem. -1, 4 is right there. C is at the point -2, 0. So there's -2, 0. That's point C. And D is at the point 3, -5. So D, 3, -5. There's the point. There's our original. So that's the pre-image. Let's see. We want to move the quadrilateral ABCD 3 units to the right, 1 unit down. 3 units to the right, 1 unit down. Here's our translation matrix. 3 units to the right, we're adding 3 to all the x's. 1 unit down, we're subtracting 1 from all the y's. So we need to add those two matrices together. And A prime will be at 2 plus 3, 5. 3 plus -1 is 2. So it's at the point 5, 2, which is right there. I've graphed it. Let's see, for B prime, we're going to add -1 and 3 and get 2. We're going to add 4 and -1 and get 3. So B prime is at the point 2, 3. And it's graphed there for you. Let's see, C prime, we're going to add -2 and 3, which is 1, 0 and -1, which is -1. So C prime is at the point 1, -1. Let's do D. Let's get to D prime. We need to add 3 and 3, we get 6, add -5 and -1 to get -6. There's 6, -6, and there it is after translating our pre-image, 3 units to the right and 1 unit down using matrices. Performing a dilation. So step 1 is to graph the pre-image, which I already did. Directions are at the bottom. So we have triangle ABC, and it has the following vertices. A's at the point 5, 1. B's at the point 3, -2. C's at the point -3, 5, and they're already graphed, but there's our vertex matrix. So we are going to, in step 3, multiply the vertex matrix by the scalar factor using scalar multiplication. So our scalar factor is given to us down below, which is 2. So we're going to multiply every single element in our vertex matrix by 2. So let's see, A prime, 2 times 5 is 10, 2 times 1 is 2. B prime, 2 times 3 is 6, and 2 times -2 is -4. C prime, 2 times -3 is -6, and 2 times 5 is 10. Let's graph these. A prime is going to be at 10, 2. B prime is at the point 6, -4, and C prime's at the point -6, 10. There is A prime, 2. at the point 10, 2, B prime is at the point 6, negative 4, C prime is at the point negative 6, 10, and there it is after a dilation with scale factor 2. Example for dilation. We're going to graph our pre-image and our image. The directions are off to the top right. We have triangle ABC. It has the following vertices. So A is at 9, 3. So let's graph that. There's A is at 9, 3. B is at 6, negative 9. So I'm making the vertex matrix and I'm graphing the points at the same time. So 6, negative 9 is down here. B. C is at the point negative 3, 6. So graph that, negative 3, 6. There's a pre-image. This time our scale factor is negative, 1/3. So we're going to do 1/3 times our vertex matrix. Or it's the same as dividing everything by 3. What's really cool is they are all multiples of 3. So yes, they're going to be integers. So let's see. 1/3 of 9 is 3 for A prime. 1/3 of 3 is 1. So A prime is at the point 3, 1. Let's do B prime. 1/3 of 6 is 2. 1/3 of negative 9 is negative 3. Let's graph that. It's the point 2, negative 3. 1/3 of negative 3 is negative 1. 1/3 of 6 is 2. That gives us the point negative 1, 2. There we go. We performed the dilation with scale factor 1/3, and there is the image. We have finished transformations using matrices, translations in dilations. This is Vicki Gaines. Hope you learned something new. Until next time, see you later.